Today we're going to be doing Unit 6, Learning Target 5. So today we're going to be talking about compound interest, which is an extension of exponential growth. So let's go ahead and let's take a look at some examples of exponential growth to kind of get us back in remembering that. So let's take a look at this one. In 1982, there were 84,105 females in high school sports. Since then, the number has increased an average of 9.4% per year. So remember, whenever you have a percent, you want to convert it to a decimal. So we're going to move it left 2 places. So the decimal for that is going to be 0.094. So our starting point is 84,105. So I get y is equal to 5. Then I'm going to do 1 plus my rate. And I'm going to raise that to the x because right now I don't know how many years that is. But I do know that we're starting in looks like 1982 on yours, so let's use that one, in 1982. So then, let's go ahead and let's take a look at actually solving this. So we want to figure out how many years passed between 1982 and 2005. So 1982 minus 2005 is going to give us 23 years. So let's go ahead and let's plug that in. So I have 84,105 times 1.094, and that's going to be raised to the 23rd power. So when you do that, you end up getting 664,079.7. Okay, so now we don't want to talk about 0.7 of a person. That's not very nice. We don't want to define what 0.7 of a person means. So we need to round it, and since this number is greater, we need to round that number up. Well, since we're rounding that number up, we're going to also have to round that number up. So let's go ahead and let's take care of that. So when we do that, we end up getting this right here, and it's going to be females. So that's how many females participated in sports right here. So that's exponential growth. Now, let's take a look at compound interest. Okay, so here's the formula for compound interest. You're going to write it in that first box there. Is A is equal to P times 1 plus R over N T. Or over R over N and then raised to the NT. So A is going to represent your ending amount. Okay, so this is for all your variables. B is going to be your starting amount or your principal. R is your interest rate. Remember, if it's written as a percent, you do need to convert it to a decimal. N is the number of times it's compounded each year. And then T is going to represent the number of years. Okay, so let's go ahead and let's take a look at some possible values of N. So we're just going to write that down here. Okay, so let's take a look at some things that N could be, and we're going to write that. So if it says monthly, if it says, okay, it's going to be compounded monthly, that means your N is going to be equal to 12. If it says quarterly, think about a quarter. There are 4 quarters in a dollar. Quarterly means 4. Okay, semi-annually. So if you think of a semicircle, it's half of a circle, right? So half of a year and half of a year. So that's going to be twice a year. Weekly, well, now we need to think about how many weeks are in a year, and that's going to be 52. And finally, daily, we need to figure out how many days are in a year, and that's 365. So we're going to be using those N values throughout our practice problems today. So let's go ahead and let's take a look at number 2. So it says that Marie's parents invested $14,000 at 6% per year. Again, converting that to a decimal. So here is my P. Here is my R. Whenever you see the word compounded, that's how you know to use this formula. If it says compounded, then you need to use the formula given. Okay, the one that we're using today. Monthly, well, we talked about monthly means 12, so that means my N is 12. How many will there be in 10 years? So that means that my T is equal to 10. So let's go ahead and let's plug that into the compound interest formula. So I have 1,400 times, whoops, let me write that out a little better for you, 14,000 times 1 plus my rate, which is 0.06, divided by my number of times per year, raised to the number of times per year times the number of years. So when you're going through and calculating this out, you need to take the extra step of multiplying out the exponents. So then when you do this, okay, you end up getting an exponent of 120. So now you can go ahead and plug that into into your calculator. Remember, if you're using the crappy ones, to put a time symbol outside of the parenthesis. So when you do that, you end up getting 25,471.554. Now, when you're talking about money, you only want to use 2 decimal points. So you always have to look at that third decimal point. If it's 5 or above, round up. 4 or below, you can keep it the same. So then our final answer is going to be 25,471.55. So that's how much money you would make after 10 years if you decided to invest your $14,000 in that manner. Now let's take a look at another one. Determine the amount of investment if $300. Okay, so $300 is our start point. So this is going to be our P. It is invested at an interest rate of 3.5, so that means 0.035 is our R. Semi-annually, so that means that our N is going to be equal to 2, and for 22 years means our T is equal to 22. So now we just go ahead and plug it into the formula. So I have 300, and then I have 1 plus 0.035. Now I don't need to put in the P, the R, the T, or the N, or anything like that at this point. Divided by the number of times per year, which is 2, raised to the number of times per year times the number of years. Now you do need to take the extra step out to multiply out the exponents. So I'm going to rewrite my equation. You really don't have to simplify in the parenthesis if you don't want to. I usually save that till the end to avoid rounding early. 2 times 22 is 44. So now I'm going to type that into my calculator. 300 times 1 plus 0.035 divided by 2, all of that raised to the 44th power. Well, when I do that, I end up getting 643.629. Again, when we talk about money, we want to keep it to 2 decimal points. So since the 9 is 5 or greater, we need to round that 2 up. So we have 643, and then we're going to make that 0.63 when we round that 2 up to 3. Okay? Let's go ahead and let's take a look at number 4. Again, we need to start assigning some variables. So our initial investment is 400. So that means that we're starting as our P is equal to 400. Now our interest rate is 4.3. So as a decimal, that's 0.043, and that's my rate. Compounded annually. So if it says annually, that really only means once a year. So that means your N is equal to 1. And then it says for 15 years. So our T is equal to 15. Let's go ahead and let's plug that in. So we're starting with 400, and then I have 1 plus 0.043. Then I'm going to divide that by the number of times per year, which is 1, and raise that to the number of times per year times the number of years. So now I need to multiply those out. So I get 400 times 1 plus 0.043, and all I'm going to do is multiply out that exponent to give me 15. So now I can punch that in my calculator. I strongly encourage you to have a calculator out and try typing it along with me so that you make sure you get the right answer. So 400 times 1 plus 0.043 divided by 1 raised to the 15th power is 752.814. Again, we only want 2 decimal points. Well, since this is below 5, we can just cut it off. So that makes our answer $752.18. So that's your final answer for number 4. Now, let's take a look at number 5. So, for number 5, what we're going to do is the same thing. So, we're starting with an initial investment of $1,200. So, again, that's our P value. The interest rate is 2.6%, which is the same as 0.026. Okay, that's our rate. Compounded weekly, we know that there's 52 weeks in a year. That's why N is equal to 52 for 13 years. So that means that T is equal to 13. So let's go ahead and let's write this out. So we're starting with $1,200. We're going to do 1 plus our rate, which is 0.024. Divide that by our number of times per year, which is 52. Then we're going to raise that to our number of years times the number of times per year. Remember, you want to take that extra step to multiply out your exponents. So I have this, and then when I multiply that out, I end up getting 676. So I'm going to take 1,200 times 1 plus 0.024 divided by 52 and raise that to the 667th power. Now when I do that, I get this. So my third number is 5 or greater, which means I need to round this guy up. And then I'm going to draw the dollar symbol because all this is talking about money. So that concludes your note video for today. Please let me know if you have any questions. Thanks for listening.